Hey, welcome everyone into the NGK Tech Garage. Today we are working on a 2007 Dodge Caliber. This thing's got the 2-liter 4-cylinder engine in there. This is non-turbo. And we're looking at a complaint today of a severe drivability issue. The thing just runs like garbage. It was actually towed in. There's no throttle control on here at all. It doesn't, you hit the gas pedal and really nothing seems to happen. It doesn't really rev up much. It doesn't run right at all. It feels like it's misfiring. The engine's running terribly. Check engine light is on. And this comes to us from another shop. If we actually take a look under the hood here, you'll see that this thing has, maybe you'll see, you can't see the coils, but there's 4 ignition coils here that are all brand new. You can see the wiring for all the injectors, the sheathing or the protectors around those wires have all been stripped away. And if we look over here, you can't really see it, but that is a new PCM in here. This car has spent a lot of time in another shop. So this has, I was told this is now the 3rd PCM that's been installed. It was programmed at the dealer. Everything is working right, or we think is working right with the PCM. Again, injectors have been looked at the very least, if not swapped around potentially, and coils have been installed. So this thing's had a lot of parts thrown at it. So we're going to take a look. Let's first just start with looking at how bad this thing is running. Now, of course, I do have the air box or air snorkel or intake tube, whatever you want to call it, is off right now because I am going to have to get to the throttle body. But I just also wanted to show how nasty this air filter is. Change your air filters, they can lead to drivability issues. So we're not even going to use any of that today. We're going to run the engine right off the throttle body, and it should run relatively smooth. This is a non-mass airflow sensor car, so the only thing in the air intake tube itself is intake air temp. So in a good running car, this thing should run pretty nice right now, and as you can probably hear and see, it is not running well at all. You can see how much it's vibrating. But what's really interesting with this vehicle is I can go like this. And let's get a shot of the throttle body up on the screen. All right, you guys can hear me revving this thing up. And there's no throttle control whatsoever. So this little engine here is able to be revved up just off of the accelerator pedal position sensor. I can get to almost 3,000 RPM just off of the accelerator pedal position without the throttle body opening at all. So kind of interesting, but seeing the throttle body like that leads me to probably a throttle body issue. And if we look at the codes, you'll definitely see we're showing a throttle body issue, a P2119 throttle actuator control performance code. So there's something wrong with the throttle body circuit. It's also got an engine oil pressure code. Probably just needs a engine oil pressure sensor or something with the circuit. We're not going to look into that today. It's also got an intake air temp circuit or a sensor code. And again, that's because our intake air temp is mounted in here. So not something that we're gonna worry about. That's a code that we've caused. Okay, so we got a 2119. We're gonna go out. I already have the vehicle built in Identifix here. We'll just do a search on a 2119. And well, it comes up with a pretty big throttle body issue, right? We're seeing a lot of throttle body problems. So Identifix says it needs a throttle body, right? Order one up, put it in, and fix the car, right? Right? Is that how it works? Well, we should do some testing, of course. So what can we do for testing on this throttle body? Well, there's a couple things we can do. First thing we want to look at is what exactly sets a 2119. There's a lot of possible causes here, right? You could have a motor problem, a throttle. Again, this is electronic throttle control. You could have a motor problem. You could have a harness issue. So a lot of different things that it can be. So let's start with looking at the obvious things that we can check out with the scan tool, right? We don't want to have to work too hard right off the bat. So we can go into some data on the tool. We can go into throttle data. And let's take a look at what we have. So obviously we have engine speed, APPS, TPS. So let's first look at our throttle position sensors. If we go ahead, we'll open those up right there. So both TPSs are obviously built into the throttle body assembly, and they're both reading roughly what I would expect. And if I go ahead and stick my hand down in here and move this throttle plate, you guys can see as I push on that throttle plate, we're getting movement out of the TPS. So do I think that I have a throttle position sensor problem? Probably not, right? We move it down the line because I can see something happening from the TPS going into the PCM and then showing us on the scan tool. So let's go ahead and fire this thing up once more and take a look at that data and see if we get any throttle position movement when I go ahead and actually try to open the throttle. So if we look at APPS there, we're wide open throttle, 100% pedal position, nothing on the throttle is moving, right? So again, we've confirmed that we have no movement on the throttle body at all, okay? So our TPS seems to be working, throttle position is working, APPS is working, accelerator pedal position, but no movement on the throttle body itself. So maybe we have a control issue. Maybe I believe these are PCM controlled, so why don't we go ahead and look at what actually supplies power and ground to this throttle body motor. If we go ahead and look at the wiring diagram, we have PCM control at the top and bottom of the diagram with the throttle body in the middle. Go ahead and zoom in. We have a 5-volt supply, ETC positive, TP sensor ground, ETC negative, and then our 2 signal circuits, okay? So the 5-volt supply, sensor ground, and TP signal 1 and 2, we've pretty much confirmed their operation just by doing the testing with the scan tool. We were able to move the plate itself, show a change in TPS, and our voltages seem normal for a key on, engine off type of position, a closed position. So really we're not too concerned with 1, 2, 3, 4 of these circuits on this throttle body. What we are concerned with is ETC motor positive, or negative and positive. But what's interesting about this is that even though we're saying it's motor positive and motor negative, these two right here have the ability to change polarity. They can switch polarity. So a motor, you supply it with power on one side, ground on the other, it's going to move one direction. If you flip-flop those polarities and you supply power and ground opposite, you're going to move that motor back the other direction, okay? The PCM has the ability to do that on this vehicle. It's supplying power, it's supplying ground, and then it inverts or switches the polarity to supply power and ground to run the motor the opposite way. It does this very, very quickly, and that's how we're able to control the throttle body with this thing. So what I've done is I've already gone ahead and I've back probed the pin 1 and pin 25 at the PCM. So if we look at the diagram again, we're back probed right here and right here on the PCM. So what we're going to do is we're going to watch the actual control of the PCM trying to control this throttle body. So if we take a look at, let's get the lab scope opened up here. I have the scope on it and I also have a meter on it. And we're going to look for a 12-volt control. So I have the meter right about there. And we'll get the lab scope set up for, this is a 12-volt circuit, so we'll set it at 20. Turn up our time frame a bit. We'll go 5 seconds per division. Turn up our sample rate, so we're reading 20 volts. Let's go ahead and change our offset a little. Alright, bring this guy down. Okay, so lab scope is pretty much prepped at this point. Both are going to sit at the 0 mark. So when we key on, a throttle body is supposed to go through like a quick test. We should see a voltage spike, a key on, and we have nothing. Alright, now if I go ahead and start this thing up, I should see some control or change or something happening, and we have nothing. And if we go ahead and look at the meter right now too, we have no power or anything on the meter. We have nothing on the lab scope. So So we have no control coming out of the PCM. The PCM is not supplying power, it's not supplying ground, something isn't doing what it's supposed to. So do we just have a throttle body issue, or now do we have a PCM issue? Again, this is a new PCM on here that was programmed and everything at the dealer. It was all done right. So we have some problems here, right? Now my gut right off the bat says I don't think we need a PCM, but we don't know that for sure. Let's verify the throttle body first, make sure that that is actually faulty. It could be a wiring issue potentially. So let's verify that first, and then we'll look at some PCM controls. So if I go ahead, the throttle body is unfortunately kind of buried on here, but I'm going to go ahead and I'm going to pull that out, and we can actually pull that out and have it still connected to do some testing with it. All right, so as you guys can see, the throttle body is out. This is the old throttle body. This is, I would probably assume, to be the original throttle body that's on this vehicle. So these things have a lot of issues. So what can you do to verify that this is actually the problem here, right? Because we don't want to just throw a throttle body at it. This is probably a pricey unit, and it's really a guess at this point, right? We don't know if we have a control issue or a throttle body issue. What can we do? Well, there's really two tests that we can do on this motor circuit. Like any motor, it's just a coil of windings, a coil of wire, like most motors, I should say. It's a coil of wires. So what we can do is we can do an ohm test on this motor, but that's really not going to do us any good unless we have a known good value to compare it to. And I was unable to find one. We can compare it to the new throttle body if we get that far. But we can do that, and then we can also supply power and ground. Just like the PCM would, we can supply this thing with positive from the battery and negative from the battery and see if it moves. So let's do an ohm test on it first. Grab my leads, and it's going to be the two, make sure my head's out of the way here, but it's going to be these two furthest forward pins are actually going to be the motor circuit on here. The other four are all part of the throttle position sensor. So if I go here and here, and we'll do a resistance test. Let's see what we've got. All right, 1.7 ohms. But again, is 1.7 good or bad? You know, it's a motor. It's a coil of wire wrapped and wrapped and wrapped around a bobbin. Is 1.7 good or bad? We don't really know that answer without a known good. So does this test really does it hold a lot of value for us? And the answer is probably not, right? Unless we have a known good throttle body to compare against. But we can go and we can supply this thing with power and ground and see what happens. So I'll go ahead and I'll tip this thing up so you guys can see. And here we go. So we'll go ground and power. And I'm connected to the battery. I don't know if you guys can hear that. Let me get the mic close. Okay, I don't know if you can hear that, but the throttle body's trying to do something in one direction. Now, I'm going to take and I'm going to reverse the polarity. So I'm going to take black and red and flip-flop them, right? Because we're going to try to run the motor the opposite direction. All right, so we're flip-flopped. Still, not doing anything at all. So we have a bad throttle body. I would say at this point we are confirmed. It does not move when power and ground are supplied, and our resistance reading is 1.7 ohms. Don't know if that's good or bad, but we confirmed with battery voltage that this throttle body is not moving. Okay, great. We need a throttle body for this vehicle, but do we know if the control side is okay? Is it possible that our throttle body motor shorted out or caused damage to the PCM drivers? It's possible, right? We saw no voltage command, no current, no anything happening out of the PCM when we tried to move this throttle body motor. So it's also possible we could have a circuit issue, right? We could have an open circuit between the PCM and the throttle body itself. So let's go ahead and do some quick open circuit testing. So what we can do, what I like to do is I like to load test a circuit because the resistance value is not going to be a valid test. You can get a known good resistance value out of one single wire, but it won't hold any current. So we're going to just run this circuit in a loop with a small bulb. All right, so we got a small bulb here. This thing's going to probably pull about an amp or so on a full 12-volt circuit. And anytime you're load testing with a bulb, they can be tricky, right? If the bulb is dropped or something, you always want to just verify that your bulb actually functions prior to, the worst thing you could do is use a bulb and test the circuit and think the circuit's bad and chase a wild goose chase. So we already have the PCM back probed, okay? Right, we're back probed into the PCM using our leads here. So what we can do is we can just disconnect. What we'll do is we'll make sure the key is off. It is. We're going to disconnect the PCM on here, and I'm going to use my two back probes just as a source to connect into this PCM circuit. So what we've done now is I've disconnected here, and if we look at this on a wiring diagram, I've disconnected this connector right here, okay? Obviously, since our throttle body is sitting out right now, this connector is disconnected as well. So what I'm going to do is I'm going to run the bulb between pin 1 and pin 4, and I'm going to supply power to pin 1 and ground to pin 25 with both connectors disconnected. So what we're doing is we're testing from connector to connector with the PCM and the throttle body disconnected. So again, I'm going to take our connector wherever it is here, and I'm going to feed in pin 1 and pin 4 at this connector. I'm going to try to feed this in here. It's probably not going to work. I'm probably going to have to grab some back probes. I'm going to attempt to feed this in here. Yeah, it's definitely not going to work. So I've got these test leads that I was using for the other side of the throttle body. We're going to use the male test leads now. We're going to go into pin 1 and pin 4. And these are way safer than going in with a back probe or something because you're not going to spread the terminals using the properly sized test leads. So we're going to just take the bulb and we're going to set it in here for now. Well, that's where it's going to end up. But what we can do then is I'm going to just take a set of jumper leads. So all I've got here is 2 jumper leads, and yes, technically these should be fused. I'm going to unplug my scope leads up here, hook one end to there, one end to there. All right, and black to black, red to red, and we've now supplied power and ground. If we look at the diagram, we've now supplied power and ground up this wire right here. We're supplying power. This wire, we're supplying ground. And I'm going to take that bulb and I'm going to put it across this terminal to this terminal. Again, we're unplugged on throttle body and powertrain control module. Never ever hook a PCM connector up to power and ground unless it's unplugged and you're just testing the wire. You never want to short power or ground directly into that PCM. You can fry the drivers, okay? Disconnected. It's imperative that this connector is disconnected before you supply it with power and ground. Now I'm going to take this circuit on the opposite end and put the bulb across here, and someday I'll put some banana jacks or something on this bulb, but there we go. Okay. Test complete. It's able, this circuit, this wiring from connector to connector is able to pass 1 amp of current. I'm okay with that. It's probably not an adequate load for the circuit. This throttle body probably pulls a couple more amps than just 1, but it's able to pass 1 amp, which is a way better test than doing any sort of resistance testing, okay? An ohm test for this would not be a good test. So our wiring passes. Kind of still don't know if the PCM is bad, right? We haven't confirmed or denied that at this point. We don't know that for sure. Let's go ahead and get these jumper leads out of the way. But we know that the throttle body is bad, and we know that the PCM is able to, well, we know that the wires are good between the throttle body and the PCM. So I'm going to hook our scope back up, let's go ahead and take a look at a new throttle body. Okay, so here's a brand new throttle body, or maybe reman, I don't know. Came out of the box, it looks new. So let's take a look at that resistance spec on the new one. Again, we were like 1.7 on the old one. Let's take a look at what the new one is. So again, same pins, pin 1 and pin 4 on the new throttle body. Hook into there, hook our other end up to the meter. All right, so our new throttle body motor. That's a significant difference, right? 10.4 ohms, 10.3 ohms of resistance versus 1.7, okay? According to Ohm's law, if we take 12 volts, we're going to use that as our constant, right? And we send it through 1.7 ohms of resistance, our current will be whatever it is, do the math. If we send that same 12 volts through 10 ohms of resistance, our current will be whatever it is, do the math, but it's going to be significantly lower, right? 12 divided by 10 is a much lower number than 12 divided by 1.7. So we end up with a lot more current potentially running through this old throttle body. Is it possible that we've smoked this PCM? It's possible. It's possible that the PCM has smoked itself, okay? So again, gut feeling probably says not, considering this is a brand new PCM, but you just never know. So I guess just to verify real quick, show you guys that the test actually works, I will supply power and ground to the new motor and just show you that this thing is able to be opened and closed with the changing of polarities. Okay, hook in power and ground, and we'll go red to black first and black to red. Okay, and you don't really want to hold it on there forever. Okay, so I'm able to go that way. We'll switch up our cable here, and that forces it closed. Okay, so new throttle body moves, 10.3 ohms or so, I guess I would consider to be a good spec, but still, we're not confident in the PCM not being an issue. So what I'm going to do is I'm just going to take, I can get this connector up far enough here, I'm going to take and I'm going to plug this thing in, and now there is a throttle relearn on this vehicle. So we're going to plug this guy in, maybe. And unfortunately, our connector is kind of damaged on here. Make sure you plug it in. It only goes in one way. There we go. So it's plugged in. Good to go. PCM is reconnected. So I'm going to go ahead. I'm going to flip the key on, and we're going to do a relearn. All right. Key's on. And the throttle body is not bolted to the intake manifold right now, so we're not going to fire this thing up. But I want to see if my PCM is bad, if it's able to control this thing. So go ahead, and I'm just going to do a codes clear. We want to start back at fresh, so clear out the codes. All right, DTC is erased, great. And we're going to go into system tests. We're going to do ETC learn values. And what this is going to do is this is going to learn the values of the new throttle body. So okay, DTCs are reset during this test, so that's good to know. So hit continue, follow the prompts, okay. So it's waiting for the test to begin. It doesn't want you to touch the accelerator pedal. Let's go ahead and let's bring up the scope on here with the scan tool up on the screen, and let's watch the scope to see if we end up with any sort of control. And let me bump my lines up so you guys can see them. Let's see if we end up with any sort of control happening now. Okay, press the accelerator firmly to the floor. So right now it's most likely watching APPS, right? So I just put the pedal down to the floor, it's held firmly on the floor. Still no voltage control, no difference coming on the scope. Release the pedal. Okay, learn complete. Kind of odd, right, that during the learning the throttle body never moved. I don't know if it's supposed to or not. It doesn't say that information. But I'm going to go ahead. Let's bring the scan tool back up. going to hit continue. And let's take a look under the hood. ETC learn is passed. Hit continue again. Something just clicked. The inside of this thing just dinged. I don't know what that was. But now we should be all set. But that dinging was actually this thing setting another code. We're setting a 2919 code still. It's still not doing what it's supposed to. Okay, so new throttle body on here, and we still have no control. I can go in here, I can hit the gas, and nothing is going to happen with this throttle body. Nada. No control. Now let's look at the lab scope. I'm going to go ahead and I'm going to turn the key on and off, or off and on. And again, we should see something happen. There should be a voltage spike. There should be something when you key cycle this thing as an initial quick turn on. Still, nothing. New throttle body. Verify the wiring. Time for PCM. This would then be the third new PCM, the fourth PCM installed into this vehicle. I don't know. My gut just still says no, you know. Maybe, but my gut says no, okay? And this is where I struggled on this car, and why this car is here for a video is because everything was telling me that the PCM looks like it's bad. It's not controlling the throttle body as it's intended. My wiring is okay, my throttle body is now okay, but something still doesn't make sense. I passed my relearn, no problem with the scan tool, but something still doesn't make sense. So I went out and scoured the internet. I was looking through, I Googled problems, I was looking through everything. I went into Identifix, and I don't remember which one it is that I clicked on. Maybe it was just this first one here, whatever it was. PCM issues. There was one in here that really pointed me right here. This guy right here, Sears Auto Center, put in a note in here, and I'll zoom this in so you guys can see. This saved me from putting a PCM in this vehicle. Also, key to testing feed wires. Make sure the intake air temp sensor is plugged in. IAT, for whatever reason, seems to be a vital, critical issue or component maybe for testing or relearning this throttle. Okay, so let's make sure that it's plugged in. Again, it's been unplugged this entire time because, well, I'm not going to install this throttle body yet if I think the PCM might still be bad. So that's why it was never fully put back together, is because we always kind of had this feeling we might have a PCM issue. So now, let's go ahead, plug our IAT in. Okay, so IAT is plugged in. All right, I'm going to go ahead, I'm going to clear the codes again. Okay, and let's go system tests. We'll do ETC learn. Okay, okay, okay. And let's bring up the lab scope on the screen. So again, we're doing a voltage learn. It's learning the values. All right, press the accelerator to the floor. There we go, we're on the floor. Still no change in our voltage. Hold it to the floor, okay. Release. Don't touch. All right, we're gonna stay on the scope and watch this. Continue. ETC learn is passed. So same message that we saw before, but watch the scope. I'm gonna hit continue. Still nothing. Okay, we're plugged in. Everything is plugged in properly. Let's go ahead and key cycle this thing and see if we get any change. Look at that. That's what we're looking for. Every time you key cycle this thing, it will actuate that throttle body. The throttle body should move with every key cycle, okay? It does not do that unless the IAT is plugged in. It will pass the learn every single time, and it will think that it learned it, and it will not work. It will not function unless you have the IAT plugged in. okay? And when we're looking at codes, how often do you think an IAT has a huge factor on whatever you're doing for a drivability complaint? That's just like looking at, let's go into the codes here, just like looking at an oil pressure circuit code. How often do you think an oil pressure circuit code is going to affect something on the vehicle? It's possible, but it's one of those codes that you see pop up over and over again, and you know, it's okay, we'll get to it later, you know, it's probably not causing my issue. That's what I thought with the intake air temp sensor. You know, it's got to be all removed to get to the throttle body on here. Little did I know, and it wasn't brought up in the relearn procedure, that if that's not plugged in, it will not properly relearn, and you'll end up thinking all day long that you got to put a PCM in here. I'm glad here that I trusted my gut and didn't throw a PCM at it, even though we had a shorted, essentially shorted 1.7 ohms versus 10 ohms. We had a shorted throttle body. Even though that was the case, the PCM wasn't actually bad. What happened here is the PCM actually went into a protection or fail-safe mode. It recognized the excessive amperage draw because of our shorted throttle body, that it went in to protect itself. And then it won't pull back out of that protection mode until it recognizes the proper parameters for doing the relearn. And it never calls out that the proper parameters must include an intake air temp sensor input. For whatever reason, the PCM is programmed, the coding in the PCM is programmed to only properly allow the PCM to reapply current to this throttle body if it was programmed with an intake air temp circuit, or an intake air temp value. Okay? So the scan tool will pass that all day long with the intake air temp unplugged, and the PCM will not function until it sees the relearn performed with a known good IAT. Okay? This almost burned me. This almost led to a fourth PCM being installed into this vehicle. Now, we don't know for sure yet if the vehicle actually runs great afterwards. You know, it's got aftermarket coils on top from a certain source that's not us. It's got a lot of stuff done to it. So I'm going to go ahead, I'm going to slap this throttle body on. I'm going to get everything back together here, and we'll get this thing started up. All right, so the new throttle body is all installed. New gasket, new throttle body installed in here, bolted back down. I didn't put the air snorkel and everything back on, left the IAT plugged in, but didn't put that back on because I do want to show you guys that the throttle body is now moving like it's supposed to. So I'm going to actually go out and we'll do a codes clear. Go ahead, click yes, codes are cleared, okay. And actually, when I cleared the codes, it's kind of cool, but if we look at the scope, look at that. I cleared the codes and we saw a command here for the throttle body to move a little bit for whatever reason. So I'm going to go ahead, we'll pull up data. Let's pull throttle data. And let's just go with a custom graph, get some of this stuff out of the way. TPS 1 and 2, APPS, we'll just do some comparison in graph view. TPS is at the top, APPS at the bottom, and then we'll look at the scope and we'll look at the throttle body. Let's go ahead and I'll fire this thing up and we'll see how it runs. Shiny new throttle body on there. Here we go. Oh, hopefully I didn't lose the scan until I just turned the key off by accident. Oh, it sounds better already. All right, so the first thing to note is obviously no difference really right now with the throttle position besides the fact that we did see it move. But as you can see on the lab scope, we have a very, very fast control happening here. Just take a quick look at how fast that is. Go ahead and stop this. Oh, come on. Uh-oh. Let's try that again. Okay, let's see what we got here. So it's an incredibly fast control on this throttle body motor. We're pulsing this thing at 146 microseconds. This thing is being turned on and off, okay? So it's incredibly fast, the control for this thing. Now let's see what happens when we go ahead and hit the gas here. We should see the throttle body open up, and we should see a good response out of the TPS. All right, we can see the throttle body moving. We see TPS moving, APPS moving. I'm going to do a quick wide open. All right, obvious movement there. I'm going to bring the lab scope back to live so you guys can see it. I'm actually going to pull the scale out of here so it's all the way on the screen. There we go. All right, so you see how the blue line pops up there? That's when we reverse polarity and we brought the throttle body back, okay? Open and close, okay? That's changing the polarity, moving this throttle body open and closed. All right. Sounds like it's fixed. Go ahead and shut it off, and we'll just check codes quick. I would assume there's probably still an engine oil pressure circuit, sensor circuit code. Just take a quick look. So it didn't actually clear out this 2119. That's interesting. Even though we've hit clear. Okay, says it successfully erased. And now it actually did. Okay, so now we have no codes. We're good to go. That's I guess that's a confirmed fix. I guess just to sum it up, throttle body on an 07 caliber should be around that 10 ohm mark resistance across the motor. It is possible that maybe the PCM could be damaged by a shorted motor like this, but our PCM went into protection mode here, saved itself, and it didn't come back out of protection mode until we did a proper relearn. And that proper relearn, again, the kicker here is making sure your IAT is plugged in. Scan tool manufacturers, if you're listening, give us a note. Put in there somewhere, when it's one of those buttons where we hit continue going through the procedure, tell us to make sure the IAT is plugged in. This car relies on it. It would have saved me a lot of headache and a lot of potential of throwing a PCM at this vehicle. It would have saved potentially the previous shop who worked on this thing. This thing might not have even ended up here with a simple note like that. So for those of you that are watching, I hope this video has helped. I hope this helps you figure out what's wrong with your car. IAT is imperative to have functional when working with a throttle body. And maybe this is across Dodge and Chrysler in general. Maybe it's not. Maybe it's only for the Caliber. We don't know that information, unfortunately. But just keep that in mind when you are working on these things, and really anything throttle related or anything in the future. If you have a fault in a different type of system, I mean, it's still drivability related, but it's kind of a different type of thing. It could affect other things that you're trying to relearn, okay? So I hope you guys enjoyed this video. I hope this helps you fix whatever you have in the shop today. If you really did enjoy it, please give us a thumbs up, subscribe, click on the little bell icon so you can get notifications when we come out with new stuff. Really appreciate you all watching. Thanks again, and we'll see you again next time in the NGK Tech Garage. Happy wrenching, everyone. Thank you. All right, we're not quite done. I wanted to just take a quick second to explain the circuit or the control of the throttle body. We've already fixed the car. That's all behind us, but I just wanted to quickly take a second to explain how it worked, why it does what it does. So if we look at the lab scope right now, guys, we have what looks like an incredibly messy circuit. Again, that control circuit that we measured before was at 146 microseconds. So if we zoom in super far here, and again, we're going in just ridiculously far. Again, 146 microsecond pulse here up to 12 volts or battery charging, and then back to ground, okay? But this here is not actually, and I might have misspoke earlier, is not actually controlling the throttle body. This is actually checking the circuit for the throttle body. We don't actually see the control until we get further in to our graph here. And the easiest place to see it is when I went ahead and I goosed the throttle. So like right in here, we're actually seeing some control happen. All of this right here is circuit integrity, circuit verification, because we're working with a throttle body, guys. We're working with a drive-by-wire system. There's no cable on this car whatsoever. So we're working with a system that needs to be constantly monitored incredibly quickly to verify we don't have any faults, or we could end up with a runaway car. So that's what all of this is in the scope right here. Right here, this is just circuit verification. We actually get into control right here where we're actually opening and closing the throttle, okay? The blue line up at the top here, supplying power and ground. If we're looking at this, this is the actual control happening when we go to full power, full ground, okay? This is where we're actually moving the throttle body. We're applying it with power and ground. Anything else here is checking circuit integrity, okay? We're making sure that our throttle body motor itself is doing what it's supposed to. We're making sure that our circuit is intact, because if it's not, we could end up with huge issues, okay? So thank you again for watching. We'll see you guys next time. Thank you.